Continuing our discussion about portfolio management and how we can have the efficient frontier based on which you should find out the weights of the stocks which are there in the portfolio. So, what we actually have there set of informations are the random variables which are the return of the prices, and as you know returns are basically given by in the numerator you basically have the difference of the investment for time period 1 minus time period 0 divided by the time period 0 which is I naught, and then you find out the average return of the sample which is given by R bars suffix 1, 2, 3, 4 till the number of stocks which you have, plus you have the variances and also the covariances which basically can be found out given the standard deviations and the correlation coefficient. Now, our main concern and our emphasis is how do we find the weights. So, is there any mathematical method? Answer is yes. As I mentioned that Markovich in 1952 in his seminal paper did discuss about trying to find out the optimum portfolio based on some optimization techniques and some rule, which we will come to that within few minutes as we discuss the problem. So, what we were discussing that you have two different stocks. So, along the x axis you have the returns which I will just write as R. Now, this capital R or small r are interchangeable. So, consider that whether it is capital R or small r, it will not make any fundamental difference in the way we discuss. And along the x axis you will basically have the risk, where the risk can be either standard deviation which is the square root of the variance or the variance or whatever risk basically concept we are bringing into the picture. Now, our main concern is to find out what is the overall shape. Now, if you remember what we had discussed is that if there were two different stocks where point A and point B were, if the variance of the portfolio is given by sigma square suffix p as in this formula in the last equation which is given in this slide, and we consider that if alpha is the overall weightages out of 1, which is out of 100 amount of rupees which you have or 200 whatever you have, if alpha is the weight for one stock, 1 minus alpha would be for the second stock. If the variances are given for each and every stock or two stock as sigma 1 square and sigma 2 square, the overall variance for the whole portfolio is given by this formula, and the square root of that will give you the standard deviation, and correspondingly the weights can be found out about based on the optimization problem which I just mentioned few minutes back. We will come to that, and our other concern is basically to find the return. So, here is in the slides which we have basically the return which is given in by the first equation. So, if you plot them, our main question is two things: find out the weights given the condition that all the input values are given, which are again I am repeating the returns, the variances, the covariances. Inside the covariances you have the standard deviations for 1 and 2 plus the correlation coefficient. Now, if you remember, let me go back to the 2 slides before. If the correlation coefficient is between -1 and +1, then obviously the overall area between which the curve will lie is basically the triangle ABC. And if you remember that if you extend these dotted lines along AB and along CA or CB, it basically gives you the dotted lines gives you the amount of short selling which is being done for each and every stock. Now, any correlation coefficient in between -1 and +1 would always be a curve. If you remember, I had drawn it like this. So, you see for example, this is for 0, this is -0.95 and so on and so forth. Now, if you look at these figures or the shapes of the curves, the concave properties and the convex properties will be utilized later on. So, basically we will consider them with such a property such that trying to find out the optimization problem in its true sense according to the assumptions would be much easier. So, now if we solve these equations which are there. So, the first equation differentiated with alpha and then put to 0 and then doing the second differential will give you the maximum return, and the second equation separately which is for the variance or the standard deviation differentiated with respect to alpha and then found out the second differential will give you the minimum amount of risk. So, that is what our main concern is, try to increase the risk or decrease increase the return and decrease the risk. Now, if we solve this equation, the two extreme points would be for the case when alpha is plus 1 and when alpha is minus 1. And if you plot these graphs, it will be basically these two lines which you have, which is basically A, C, B for value of minus 1 and A, B for the value of plus 1. Now, let us see how that this concept can be extended. So, the graphs which I have drawn are all inside the triangle ABC, and that would be the fundamental truth as we proceed for more than 2 different stocks to 3 to 4, so on and so forth. Now, for plus 1 and minus 1, we have these two differential equations. So, the first one would basically be given by the line AB, and for the mod 1, which is the second one, will be given for the point which is basically A, B and C. Now, let us extend this for the case when you have 3 assets. Consider you already have an asset, a set of assets A and B. So, their combined shape is, say for example, this triangle, which is perfectly fine. We have already discussed that. Now, let us consider that the second step we are bringing the third investment, which is an asset which is C. So, now our main question is that how should we combine them? So, our methodology of combining them and finding out the overall shape and the size of the curve is very simple. First, combine A and B, find out a point which is basically the combination of A and B depending on some proportions and depending on some correlation coefficient existing between A and B. Consider this is this point, which is a combination of A and B. Next, consider B and A are out of this situation, because the whole overall characteristic is basically this point which we mark as AB. Now, consider there are only 2 points, one is C, one is AB. Again, if you combine them using the same formula, now we will basically have a curve which is basically C1, AB and C, and the initial graph which we had was basically A, B and C2. So, I am making a difference is C2. Now, if I formulate now a new portfolio which has now basically 3 stocks A, B combined as AB and C, then again we will see the straight line joining AB would be the case for which the correlation coefficient existing between 2 stocks, where the first one is AB and the second one is C. Here it will be plus 1. And the minus 1 would be the line joining AB to C1 and from C1 to C. So, again it will be, it can be easily seen and proved that whatever the combinations between these 3 stocks would be, it will always be curves inside this triangle AB, C1, C. Continue to the next stage. Now, have the 4th stock, a D1. So, what we will do is that combine AB and C and get a new point ABC, and then in the next step combine ABC, which is 1 point, with the D and continue doing this in such a way that slowly as we bring all the n number of assets in the portfolio, we slowly get the actual frontier based on which we can find out what is the best combination. So, now suppose in place of 2 assets, as I mentioned, we form a portfolio of 3 assets, 4 assets, 5 assets, so on and so forth. Consider now we have n number of assets. So, this n is the number, which means that the I value index which we had supposed will change from I 1, 2, 3, 4 till the last value which is n. So, for each of these n number assets we will have what? We will have their standard deviations or the variances, which is sigma 1 square till sigma n square, and the off the triangle element with the covariance of the ith and the jth one, where again I and j suffixes are basically changing from 1 to n. And if I is equal to j, then obviously you have the principal diagonal. Now, likewise, if you can form a different combinations of portfolio from these n assets, likewise taking 2 assets at a time, we will have NC2 combinations, 3 assets at a time, NC3 combinations, and so on and so forth till we have the last one, which is NCN combinations. So, all these sets of points which we get at the last stage when we combine those all n number of assets one at a time, like first 2, then consider the combination of first 2 into the third, then combine the combination of first 1, 2, 3 into the fourth, and so on and so forth. So, we will basically get the feasible set or the feasible region, and this feasible region would be convex with respect to the optimization problem which you are going to solve. Now, what we mean by the feasible set and the feasible region? When we solve any optimization problem, there are some properties that the overall space of search which we will do should basically have a convex properties plus 1, and number 2 is that all the set of points which will be there inside that overall region, inside the triangle, if you remember that triangle A, B, C or A, B, C, C1 and so on and so forth, would be such that the overall search space inside the triangle would always be convex, such that trying to utilize any simple optimization problem would always give you the results. So, now hypothetically consider, and it will turn out to be true, that the feasible set for these n assets would be this region, and all the points which are marked here, which I am marking with the red this pointer, or the black one which is already given, is the set of all contending points which are to be considered in order to find out what is the best possible combinations of those W's which will give you the optimum solution based on your criteria as the investor. So, few important points. So, if you remember that initially when we were discussing the utility theory, we considered two important points. One was non-satiation, that means more I give you, more you want. Another one is that every human being is basically risk averse. That means, even though people can be classified as risk lover, risk taker, then the risk indifferent person and risk hater, we will always consider people, human beings are generally risk averse persons, such that trying to find out the best possible set of points from the feasible region becomes much more logical and much more easy for us to, in order to find out the optimum set of points. Now, an important thing to note is that we will be analyzing the portfolio choices for risk averse person with the added condition, as I mentioned, about non-satiation. With this condition, we will try to find out what is the minimum variance point and what is the set of points which gives us the optimum set. So, now what we have, initially we had the feasible set. Now, utilizing this property, we will try to basically find out the actual efficient set of points which gives us the best solution for our optimization technique, which we are going to use in few minutes. So, this curve is known as, after we have apply these properties of non-satiation and basically risk averseness, this curve which we will get is the efficient frontier, and our main task is to find out the set of points which are there along the efficient frontier. Now, what is a minimum variance set? The left boundary of a feasible set, let us consider this is the overall region which you had, and the leftmost curve is basically the one which will be satisfied by these two properties. How? Consider I draw a vertical line. Now, if I see the vertical line, if I go up, that means the return is increasing, which means the more I give to a person, more he wants, which is in a way a property which is exactly mimicking non-satiation. Point 1. Point 2 is that if I draw a horizontal line, any point to the left if I go would always mean that the same level of return would give me a less amount of risk. So, if I try to combine both of them, if I am at point A, see for example, if I am point at A, and if I am say for example at point B, so for both A and B, the risk is always the same. But if I follow those two properties, it will mean that I will always, as an investor, always try my overall portfolio to be at point A, which is one of the point in the curve, which means technically any point below B would not be considered, because at that point of B, for the same level of risk, we get the highest return. Next, consider the horizontal one, move left. So, consider this is basically A1 and this is basically B1. So, if you move left from A1 to B1, you will see that for the same level of return, we try to decrease the risk. That means, we are risk averse person, in a sense that at the boundary, our level of overall risk is the least. So, if you combine both of them, the actual frontier what we will have, which is the efficient frontier, would be just this curve. That means, starting from B1 to say for example, some point here, and obviously there would be an extension in a dotted lines. I will come to this dotted lines later on, because that has something to do with the concept of short selling. So, the left boundary of a feasible set is called the minimum variance frontier, since for any value of the mean return of the rate of the return, the feasible point with the smallest variance or standard deviation is corresponding to the left boundary point. So, there is a special point for which the variance is the least, that is known as the minimum variance point, are denoted by MVP. So, if you see the curve, I have now eliminated all the points which are there onto the right, all these points. So, they were basically totally the feasible region. Now, I have only considered the curve, and in the curve I should only consider the red one which is marked here, which means this is the best frontier which we have, which is basically the efficient frontier. And the point for which the risk is minimum is known as the MVP, which is the minimum variance point. The other extreme would basically be the point for which the risk and return are the maximum, and any extension would be coming from the fact that if you are doing short selling. If you remember in the triangle one, any extension of the line AB or CB or CA in the dotted concept would basically give us the concept of short selling. So, what we are doing here again is that we are trying to bring in the concept of short selling again into the picture. So, this is the efficient frontier, as I mentioned. The leftmost point, again for the benefit of the student, I am denoting as the minimum variance point. This is the maximum point of risk and return, and any dotted lines I have shown is basically the short selling case. So, now for the first time, if you remember, we have mentioned about Markowitz. We will now start with the concept of Markowitz principle, based on which we will consider the optimization problem, and in the starting few slides now.